last time we were together, we submitted the taxonomic classification job. We had these unknown reads that were isolated from a stool sample from a patient who had had a kidney transplant. So you're assuming that he had reduced immunity because he was probably on immunosuppressive drugs. These were big files, and so it took some time. So we said we'd just wait and come back when the job was finished. Well, the good news is it's finished, so I want to show you what this particular resource returns when you submit files like this to it. So let's go look at this job. I often go in and look at my jobs from here, but you could also go up into workspaces and click on My Jobs here, or you could just navigate to it if you know where you placed it in your workspace. So I'd click on my home workspace here, and I have a lot of folders in here, so I want to sort the ones I've created most recently. Each of these column heads are sortable, so if I click on it once, it's showing me the earliest things that I ever created in this resource. And if I click on it a second time, it shows me the most recent. Well, here's the particular folder that we were interested in. So I'm going to click on that, and it opens it up, and you can see that there are a couple jobs in here because just between us, I went through and ran one other job and saved it here. The reads are here, but this is the one that we submitted to taxonomic classification. And note that this is an indication of a job that completed successfully. There are 3 places that you're going to see this checkered flag in your lifetime. One is at NASCAR, one is at Formula One, and the other is here at BV-BRC. So when that checkered flag is waving, it means that that particular job completed. So let's take a look. So I click on the flag, and it opens up the files that came from this particular job. And up here's the information. This is the job ID. It tells me when it started and when it completed and how long it took to run. If I opened up parameters, it'll remind me of what I submitted. And it was these reads. I identified Homo sapiens as the host genome. When it says 1, it means yes, 0 means no. To save the classified reads, to save the unclassified reads, and I don't remember if you recall, but we have the Kraken 2 database, which is the standard database, and we also have the confidence interval that those particular reads map successfully to that place. It was a microbiome analysis. So now we're all caught up. So let's look at the results. So these are the typical things that we see. I'm kind of debating, what should I do first? Should I show you the stuff that I really like the best? Or should I be like a good parent and make you see all the folders and files before giving you the dessert at the end of it? Okay, I'm going to go for good parent this time. And we're going to look at the details on this thing. So we're going to ignore some of this stuff right now. And I want to click on this folder for the unpaired reads. If you had submitted like 4 or 5 different read files to this, you would have 4 or 5 different folders because it creates a folder for each pair of reads. So let's click on that. And we open it up, and it first tells us it's looking at alpha diversity, and then there's the bracket output, the FastQC, which is the quality of the reads, the HiSat2, which HiSat2 is the bioinformatic algorithm that maps the reads to the host genome, and in this case, it was Homo sapiens, and the Kraken output. Kraken is the bioinformatic pipeline that classifies the reads into a particular taxonomy. So why don't we just look at that one first? We're going to go from the bottom up. So we click on that, and look, here they are. The reads that were classified. Remember, we clicked on, we want to save the classified reads and save the unclassified reads. So here are the classified reads. Here are the unclassified reads. And I can do stuff with these. I can take them into different pipelines, different services, and analyze them. So this is good to have, and they're a good size too. So if it was like KB, it would be too small for further analysis. MB is good because they're big, but not too big, so they don't take too long. GB is really big, so that's what we originally submitted there. So I just want to click on the Kraken report. Later we'll play with these and look at them, but let's click on the Kraken report here, just so you can see what it's like, or maybe, yeah, I'll click on that, the text file. It's really long and there are other ways to look at this, but we'll show it here. So this is just showing all the reads mapped to all the taxa. So, it starts with the root, and then it goes into the cellular organisms, and bacteria is at the division. And so it's showing you the number of reads. This was the total number of reads, and this is the reads that mapped to this. So it goes down and down, and then we start getting into Clostridia, which is a class. So you can see different things in here. It just goes on and on and on. I'll show you the plots that you can see later that I like to look at better, because this is just Gus never stops. It goes on and on and on. But one thing this is useful for is if you are interested in a particular bacterium that's in here, you can search through this to see if they have any reads. For example, I could say, I wonder if there's any Brucella in this. Oh my gosh, I really didn't expect to see that. But look, here's Brucella. Very few reads are mapping to this. So I'm not too worried about it, especially when you could see something like this that has a lot more activity going on. Okay. So that's what the Kraken report looks like. So I'm going to click on the back arrow here, and here's the Kraken folder. So remember, we've got these two groups of reads here, and we're going to revisit those later. So I'm going to go up one, and let's look at HiSat. HiSat is the pipeline that maps the reads to the host genome. And here are those reads. And there was a lot of reads that map to that genome. And this is the SAM file. Now, this particular resource doesn't have any way to assemble host genomes or anything like this, but one thing that it can be used for is to look at RNA-seq, although this isn't an RNA-seq sample, but this is an instance where you could choose it to see which host genes are going up or down in response to, let's say, being exposed to a particular pathogen. So it's not important for us right now, but I just wanted to show you it. So I'm going to go up here. FastQC. FastQC is the quality, and it's showing you the quality of the reads. The reads, once the host was removed, and look at that, it's got the FastQC report. But remember, we're not going to look at those too much. We just wanted to get rid of those host reads. And then let's look at the raw reads. Now you see a lot of things here, the zip files and the HTML files. And remember, there's R1 and R2 from the forward and reverse strand. So the pipeline is looking at each of those individually. So let's look at the R1, the quality report for this, and click the view icon here. And it opens it up and it tells you some information that these were Illumina reads. These are the number of sequences. These are the number of bases. None of them were poor quality, and the sequence length was 150. And this is generally where I stop when I look at a FastQC report. So it's looking across the position of the read from 1 to 150, and it's telling the quality scores there. And you see it's a box and whisker plot, so the standard error around those. But generally, when I see everything in the green, I feel pretty good about it. These are dipping down a bit into the red, but I'm not worried about that. This, I think, looks like some pretty good reads. Now, generally, I don't look at this other stuff, but this is showing you the different cells on the sequencer and if some of them had a problem or not. This is looking at the per sequence quality scores, and that looks pretty normal, what you would see. The per base per sequence count, that looks pretty normal. The GC, yeah, called a flag on that. Here's the theoretical distribution, and this was a bit different, but you know, it would be nothing I would worry about. Nothing that I'm seeing so far would make me think, oh, I can't proceed with these reads. The per base N, the N is generally a sequencer we'll call A, C, T, and G. If it can't figure out at that position what it is, it calls it an N. And this one is not having any issues with that. And the sequence distribution looks great. The duplication levels, if they were duplicated, that looks fine. It does look like there's an adapter in there, so you might want to trim it. But other than that, this looks great. So that's what a quality report looks for. But remember, I never go past, well, I just did, but generally, if this looks good, like it's mostly in the green, almost all the way across, it's go for me. We're getting there. We're going to get to dessert. I know you think we aren't going to, but we are. Okay, we've looked in this quality report. Now, Bracken, this will be very quick. Bracken just looks exactly like Kraken. So I click on that folder. It gives me the report text, and it's just showing you the mapping. But wait till I show you this other thing, because then you're going to look at this and think, oh, well, you won't even bother to look at that anymore. Don't tell the people who program this, because they like this a lot. So we've done all of these things. This is looking at the diversity of the sample. So it's kind of cool what this pipeline does. Not only does it try to identify everything in it, it'll tell you, oh, you know, you've got a lot of diversity in the sample. Oh, you've got more of this than anything else. So there are all these diversity statistics. I think it's 5 different diversity statistics that are run on this. So I click on this, and it highlights the green action bar with possible downstream functions. We're going to click the view icon. Okay, so it's looking at the diversity. Here are the 1, 2, 3, 4, 5 different measures of diversity. The Shannon index is telling you how diverse the species in this community are. Higher value indicates a greater number of species. You'll be able to see this better when we show you the dessert part of it. The diversity index is taking into account the number of species present and their relative value. So if you have a higher value, it indicates lower diversity, like there's a few prominent taxa. And you can see it goes from 0 to 1. This is getting kind of close to 0. So it's looking like there might be some species that are dominating over others. Then there's the Simpson's reciprocal. Higher value indicates higher diversity. So that's looking pretty much the same. Berger Park Index, it's looking at the proportional importance of the most abundant species. So a higher value indicates a larger portion of the sample is assigned to a dominant species. We're not really seeing that. And then the Fisher's index is a log series distribution. So let's go back one. Okay, one more. I just keep going up, but I'll get there. One more. So when we looked at the Kraken and Bracken reports, they went on forever. And if that's all you had, you would go nuts trying to figure out what everything is. If it were me, I download it in Excel and sort by the number of reads that map to the particular taxa so I could see who is the predominant there. But you don't have to do that, because there are 2 very cool files that are produced by this particular service. And one is a chronoplot, one is a Sankey plot. So let's click on chronoplot and click on view. And look at that. Isn't that beautiful? This is showing you all the predominant species and what % of the reads they were. Like this particular one, and I don't even want to try to pronounce it because I know I'll do it incorrectly, but that was 25% of the reads. E. coli was 15%. And you can see things like 23 more. What if I wanted to see what those were? To dig into things, you could click on it and it'll spread it out and you could see what those were if you were interested. Now, when you drill into it at this point, it's looking at the percent of that particular taxa. So if I want to go back, I have to click here. There. Okay. So it's showing you the predominant viruses in that. And let me go back on this. And let's say there was something, I couldn't find it, and I'm trying to decide where it was. And I know it starts FOCA. And you notice how it's highlighting that as it comes along, so you could search for individual taxa. I know I looked for brucella earlier, but I don't think it's going to find anything because there were so few reads that map to that. And then it says 0 results. And I could click on it there. So that's the chronoplot. And it is showing you the total percent of the reads that map to that. Let's go back and look at the Sankey plot, which is another cool plot. So let's look at this. And this really more visually reflects what the Kraken output does, which the Kraken output is going through the different taxonomic levels, which you can see down here: division, kingdom, phylum, class, order, family, genus, species. Of course, a lot of them were bacterial, a few eukaryotes for the Homo sapiens, and a few viruses. All right, and so it just shows across each of these taxonomic levels where the diversity is. And it was able to get some things to species. So, for example, we have the E. coli, and it's telling me that 1.08 megabytes of these reads mapped to this particular genus and species. Now, I really like this because I'm beginning to get a good feel of how many reads it takes where I could maybe pull a genome out of this, which we'll be doing in another exercise. So I think I could get a good genome this way. I think I could get one. And all the way up to this one, that's 891, I think I can get that. I think maybe even the 137, I could get a Bacteroides ovatus genome out of this. But we'll play with this in later parts of this exercise. So these were the two dessert things, the Krona and the Sankey plot. So you can visualize that intensely detailed Kraken output. And then here's another thing of the diversity. And we have a multi-QC report. It's just taking you through some of these things and looking at this. You can go through and check this out, but I generally stop at the Kraken and Sankey plots. So those are all the results of the taxonomic classification job. So in later videos that we're going to go through looking at antimicrobial resistance genes and virulence factors that are found in this sample. And we're also going to try to pull some genomes out. So I hope you'll join me for that. Thanks a lot, and I'll see you in the later videos.